think I'm now ready. Are you on?
Yep.
Okay,
I am.
fine. So here we are at Lincoln Davis's museum, and also as his company, Stetson and Pinkham Repair Facility in Waldoboro, Maine. And we're here today to talk about some features of old outboards. And one of the features, an early feature, is backing up. And how do you reverse with these early outboards? How do you find reverse? How do you do all that? Most two-strokes, at least ones that are not rotary valve, and especially battery ignition ones, will run backwards. So the engine will actually run in a clockwise direction, propel the boat forward, but also can be started backwards. So the engine will actually run backwards and propel the boat in reverse. So,
Isn't this a feature that's a nice thought to have, but a little bit dangerous?
yeah, probably
Especially in these
dangerous
older ones?
and not 100% reliable. So it may not always start in reverse, or if the people that run these are very clever, they can actually time it so you can shut the spark off, move the timer over, and restart it before the engine completely comes to a stop, and the engine will actually start in reverse. And those kinds of things are a bit tricky, and they're not totally reliable. And so
basically, reverse wasn't something that really worked all that well or that safely until we saw the advent of the full gear shift.
The full gear shift
in the
really,
50s.
Yeah.
Late 40s, early
Yeah,
50s.
yeah,
Okay.
yeah. So, but between the early days and then, there were attempts to, and I think there was some competitive efforts to try to outdo each other's manufacturer. The manufacturers about control and reversibility.
So features were a big deal even back in the teens.
Probably then.
Features.
So-
They talk about them today. Yes.
Waterman didn't consider reversing his great two-stroke outboard, even though that it physically could reverse. But the way he started it with the crank and more of like an automotive style, it really wasn't set up to start the engine backwards. And
You really couldn't, could you? I mean, you had.
no, you couldn't.
It could.
You can't.
Backfire and go, but
Right.
the handle would only turn it in one direction.
Right. So I
Okay.
think Waterman was so content to get an engine on a boat, a portable engine on a boat, and travel along. It was really, at this time in the history of outboards, a very unnecessary feature. And I think he demonstrated that well, the fact that you could put this on a boat and somebody could actually start it and run it and go forward, go to your favorite fishing spot, was really a great goal and a great achievement. And but going beyond that, we talked about a lot of the rowboat motors that are reversible engines.
Were some of them not reversible? The rowboat motors?
Yes.
When you talk rowboat motors, are we talking pre-World War I, or are we talking
kind of.
post-World War I too?
Both.
Okay.
Both.
All right. Good.
So one of the things, the Evinrude rowboat motor got a little complicated as to, it developed its own reversing mechanism, which we're going to talk about later. We're not going to talk about that now. And because of that mechanical reversing mechanism, it was very detrimental for the engine to run backwards. But the earliest Evinrude rowboat motors did run in reverse. In fact, the first magneto Evinrudes from 1914 would run backwards, would run in reverse with the magneto. And in fact, it even says it right on the flywheel. There's actually stamped on the flywheel, like forward or reverse, depending on which way you pull the handle. So, outboard industry enjoyed some reversible outboards in the teens, and then as the technology progressed a bit, and and Ole Evinrude went back into the outboard business in 1929. He, of course, developed the battery ignition Alto. And we'll go over and talk about those, because they are a reversible engine.
You don't suppose because Waterman had that engine and didn't have it reversed, he became a lawyer later on in life after World War I. Do you suppose he was smart enough even back then to realize that there might be lawsuits involved if he had a reversible engine?
I really don't,
You don't think so? Okay.
In fact, the later Watermans were reversible.
Okay,
Yeah.
all right.
Some of them were. But again, there were also mechanisms that would have made that detrimental. So Ole comes along, introduces the rudder twin, so-called rudder twin, in 1921. This one is a little bit newer. It's not quite a 21, but it's still basically the same layout, the same system. And these start by actually not pulling them over compression like this. This is not how you start those. You start these by having the timer in just the right place and pulling it against compression, and it fires and kicks back and runs the proper direction. But these engines run in reverse very well, and a good operator could learn to actually kill the spark with the timer handle, shift it over to the proper place for reverse, let go of it, and the engine will just kick back and run backwards.
But what about the rudder?
Well, the rudder just folds back. I mean, you can kind of try to hold it, but there's really not good steerage in reverse. It kind of works.
So with the rudder, that made things kind of tough, including that Wisconsin over there, which also had a rudder. The rudder was detrimental to reverse, basically.
Yeah. But a lot of other rowboat motors
didn't have rudders.
Didn't have rudders,
Right,
and
so they were
reversed fine.
Yep.
Alto Speedster, 1920. This one's a 1929, but they were introduced in late 27. Again, a very similar ignition system, battery ignition, and these run very well in reverse. The 28 quad, same thing. They run well in reverse. But there's some serious flaws in that plan. One of them is none of these cool in reverse. They really depend on the flow of water from the propeller up through the scoop and up into the power head, and they cool quite well in forward. But in reverse, when the engine is running backwards, there's no cooling at all.
Okay.
So that
okay.
kind of limits how long you can run it in reverse.
So if you're using it commercially, it was not a viable
No, not at
thing. So the older piston pump,
Yes,
water pump,
right,
those things would run just as well in reverse and cool.
right.
But these Altos, no. Okay.
So, and now we're going to go over to talk about the reversing magneto.
You can definitely.
Turn that off. So explain what you were doing there.
So this,
So you
this
should be
is-
starting this in forward to
I
get
could
it
be.
to do a reverse.
right. Well, we could start it either way. So what I'm doing here is I'm demonstrating that this, even though this is a magneto engine,
What engine is it?
it's a Lockwood Ash 1927 Model T, Lockwood 72T.
Okay.
And this is the last year that they offered a reversible magneto. All the newer motors after that, you could not reverse the magneto. And it has to do with where the points break in relation to the magnets. So this one's very symmetrical. It goes either way.
Okay, so
So-
it's a special magneto that allows you to reverse it like that.
Yes, it is.
Okay,
So,
didn't know that.
yeah, yeah.
So what wasn't reversible? The Lockwood Ace and the Chief are
Ace and
not?
Chief are not
Okay,
reversible.
right.
And, yeah. So anyway, what I was demonstrating is that this engine could be started backwards and to back up, or what I was doing here is I was reversing and going forward without shutting the engine off.
What's the technique?
I showed you already.
Explain it.
Stop the engine.
Right. So okay. So let's start with let's say going some nominal. All right. So the other thing we're going to talk about, and we did talk a little bit about battery ignition engines running backwards or in reverse, being reversible engines. Magnetos, if they're designed to do that, will actually spark in forward and reverse.
So you're saying that there are magnetos from this time period which were not designed to run
Right.
backwards?
Yeah.
Okay.
So
This would be,
this is the end of the line for the Lockwoods anyway, for running in reverse.
so this is a 72T.
Yeah, 1927.
Okay.
When the Chief came out in late 27, even though the flywheels look the same, the Chief is a non-reversible engine.
Okay. This is
And
the
that's
Chief.
because the way the magneto is made, where the point cam is, it prevents the magneto from sparking in reverse.
Okay, as you said, the non-reversible type magnetos had a long breaker so that they'd open.
Yeah.
And then they had quite a space where they stayed open, even though it had nothing to do with the actual
Right.
spark propagation.
Right.
But what it meant was when you tried to run it in reverse, it would not go
Right.
in reverse because
Because-
that would break in the wrong place and not
Exactly,
allow the
right.
spark to spark.
Right.
And it was a safety feature so the engine wouldn't backfire and run in reverse.
Yeah, especially the bigger outboards.
And kick up in your face and
Just
right.
it's the same problem with the Altos. Now, a little bit more about reversible magnetos. The Iseman wasn't the only one. The company that ultimately became Quick Action Magneto was Knobloch-Heidemann. And Warren Ripple bought that company and changed the name to Quick Action, and that became Johnson. The original Knobloch-Heidemann magnetos, which were available on the Watermans, Cobans, Lockwood Ash, and Kales, and many of those, a lot of those magnetos were reversible, like this one, even as a flywheel magneto.
And as reference about magnetos, you've done a previous
Right. We talked
previous
about that.
video
I
on
have a Coban
magnetos.
with a magneto ignition that runs really well backwards. And but now we're going to talk a little bit about non-reversing.
So if we have a non-reversing magneto, basically you would make a non-reversing magneto for a safety issue because
Yeah.
typically there would be no reason to make a magneto non-reversing. You'd have to think about the fact that you
I-
did not want it to reverse.
I would say so.
For safety
Yeah, yeah,
reasons. Okay.
Yeah.
All right.
So, a good example going back to Knobloch-Heidemann and Quick Action are the early Johnsons. Why would you want a reversing magneto if you could do this? Okay, if you could do
Turn it all the way around.
yeah, it won't make it.
We have to move it a little bit, but it does reverse all the way
Yeah.
around.
So-
It has no pipes coming up through, so it's one.
Right, so this is a 360-degree steering outboard, and that's what Johnson started with.
Okay.
And I think this little J over here has the same.
Same rig, yeah.
Same.
Well, no. Does it have a pipe coming up? No, it doesn't.
Yeah, so this one will go round and round too, but we can't quite.
You can't quite make it around, but you can make it around the other way.
So
No, you can't do that
the
either.
great simplistic wonder of this design means that you don't really want the engine to run backwards. It just would confuse anybody when you can just spin the thing around and go backwards.
That makes a lot more sense. It doesn't require an ability to time and have the
I think, right.
ease and
Yeah.
facility of making it
Yeah.
work. Yeah.
So now we're getting to the end of the era of reversible engines. It became really, it pretty much fell out of favor. It really, I think the last of the reversible engines were the Altos. And some of those speedsters made in the 30s, early 30s, would still reverse with battery ignition. And so the segue now is to what I call the king of the reversing engines. And that design appeared again after not being used for many, many years with the great Mercury Mark 75, as people call Dockbuster. And that started in 1957.
Yeah, I guess they developed the engine 56, 57,
Okay,
somewhere in there.
sure.
It depends.
Yeah.
Their new year started in August, not
Right.
in the.
So we're going
January.
to talk about that because that just showed up as a reversible engine long after it fell out of favor, and there was good reasons why the Mercury company decided to go with that. And Lincoln Davis here is going to go into great detail about that at the next section.
Right. Hey, Bill just finished up about the older engines with the reversing magnetos and the Alto battery-driven reversing. The king of reversible ignition systems probably is Mercury. In the mid to late 50s, they came out with a direct reversing big outboard. And the need for it was that we had big boats that we had to be able to leave from a dock and back off a dock. We had to be able to back off a trailer because these were big, heavy boats. So Kaycaver didn't feel that the metallurgy and the gearing was strong enough to handle the 60 horsepower outboard that he came out with. And also, it was cheaper and easier to make an electric reversing engine rather than a mechanically reversing engine. So what he did was he made a lower unit, first of all, that could pump in both directions. It had a water pump in it that can go in both directions, and he used these valves, these duckbill valves, to have the pump go in either direction. In other words, when the water was going in the opposite direction, then one valve would close off and one valve would open up, and it still delivered water up the water tube.
So the Alto couldn't because it didn't have a pump and it depended on
Right.
its flow of water.
We
up
had
the
to
scoop.
cool it in reverse now. We had too big an engine, and we're going to use reverse way too much because we got these big boats now, and we need to be able to have it run well in reverse as well as in forward. So the cooling was just part of this problem, but we still have the lower units that we've got in the old ones. It's just got one gear. It's got a pinion gear and it's got a forward gear. That's it. No, it doesn't change direction. He actually changes the rotation of the shaft in order to achieve reverse. So to do that, he had to figure out how are we going to make that happen. So first thing is we got a starter motor, 2 solenoids. One comes down, turns the flywheel in one direction, one goes up and turns it in the other direction. So now we've got the ability to rotate and start the engine electrically with a starter motor. It had 8 brushes in here. Very sophisticated, very well-made American Bosch starter. And it's got, like I say, 8 brushes, 8 total brushes inside. 2 fields, energized fields, that they can reverse so it'll run in the opposite direction. So in order to accomplish that, he had to have 2 solenoids. Okay, one solenoid to activate power to this side and another solenoid to activate power to this side to achieve that forward or reverse starting ability. Okay, so we have that ability. But how do we activate that? Well, we activate it through the control box initially, and you have two micro switches right here, which when you shifted the engine would activate the micro switch, push it in, and now we have continuity to run one of these solenoids. And we go back to this one, and we push this button here, we now have the ability to activate the other one. So that's how we did this. We had two micro switches with a plunger, which activated a mechanical thing to push this micro switch up, depending on whether you wanted to go into forward or reverse. And obviously it was set up so when you had the handle forward and pushed it, it did the forward solenoid and started the engine in forward, and likewise in reverse. They had little stop blocks so that they would start and they wouldn't be going too fast. Neutral was silent. That was Carl's big deal. The other problem was, how do we reverse or get the timing so it'll start in reverse as well as forward? And the control cable for this moved two racks. It had one rack on here, which was quite long to travel, and then we have another rack on the distributor itself, which had a long travel. So it was able to sweep this magneto probably 45 degrees, 35, 45 degrees, and allowed the point timing to be beneficial for starting in reverse and or forward, depending on which position it was in.
These are strictly battery ignition and...
Battery ignition, yes, absolutely.
They never mess with the magneto
No,
for this.
there was no magneto involved. Now, the next series of engines, because they had slop in this system up here, because the control box is way forward and the engine starting was way back, you had, over time, things got a little bit sloppy, so they would start harder or start easier in the wrong position. So they ended up moving the micro switches onto on top of the magneto or the distributor housing, so that the micro switches were activated way back here, and they made them more accurate. The problems with the engine were very similar to some of the early stuff. They called them dock busters, wharf smashers, because it was developed so you could back your boat off the trailer, or if you came into a dock, you could back off the dock. But what people used it for was coming into a dock to slow themselves down. They'd try and put it in reverse, and half the time it wouldn't start. So now we have a problem, and that they didn't, I don't think they really perceived. And Carl Kiekeber kept pushing and pushing and pushing. He developed this with a lower unit with an exhaust propeller, an underwater exhaust, and he spent more time and effort than it was needed. And by the time 1961 or 62 rolled around and he had these 700, 800 direct reversing engines, things had moved on. Johnson had come out with Johnson Everett had come out with a 50 horsepower with full gear shift in 1957, 58, I guess it was. And that proved to be the way to go. And Carl Kiefer wouldn't let go of this direct reversing problem, but the thing was that they didn't work well enough to slow the boat down when you were coming into a dock. And that was the biggest problem.
So when you talked about, motoring into a dock and probably waiting a little bit too long to find reverse, and you said the engine didn't start. They probably started, but it was just too late, right? I'm sure that they eventually started.
You had to crank on them, or you didn't have it quite in the right position because you're a little flustered because you're going a little too fast.
Yeah.
It was, right. If you really knew what you were doing, yes, you could do it, and it would do it every time. If you had a perfectly adjusted engine, but with a little bit of time and running, the points got a little sloppier, things didn't get quite right, didn't have quite the gas mixture, or, any number of variables, and it failed enough times so that people said, I'm not buying one of those things. They're dock smashers, wharf smashers, dock busters. We call them dock busters up here.
But sales were pretty good of those because...
Initially, yes, because they were the biggest engine made.
They were plenty
but that
fast.
was in,
right.
that was in 1957, 58.
Right.
maybe through 59,
Right.
until, it just started getting a reputation, I would
Right.
guess. And at the same time, you had Johnson with a large engine that was very shortly to be a 60 horse and then a 75 horse, and they had full gear shift.
Yeah.
And they worked better,
Right.
as far as that part of it went. Okay.
All right, so we covered the kind of the technical details of the peculiarities of this direct reversing system. And I think that the next piece is going to be, you're actually going to show one in operation.
That's correct. This is a Mark 78, 1958, on a 1958 Corson. And we'll start it up, see how it goes. Start it forward. And we're off. Belgrade Lakes, Long Pond, Castle Island, Mead. Engine at idle. And reverse.
Opposite rotation.